Hi, in this video on my Raspberry Pi with the binary counter controlled by RaspberryPi2, I want to focus on two issues. The same issues that I got left last time. The first issue is the extremely slow counting after an attempt to fix the code, but also the fact that, as you can see here, I need 2 or more times to press Ctrl+C in order to stop the program from running, and where it previously only needed 1, and then you got this setting out the values to 0, unexporting pins, deallocating GPIO objects and exiting. Now I need 2 or more Ctrl+Cs, and the question is, why is that happening? And therefore I will have to look in the code, and it is probably due to some code in here, because that is the last thing I changed. However, to be sure, I need to review the code more thoroughly, so that is what will happen next. And when I look at the binary counter more carefully, it turns out that although the control code runs for, as you can see, 8 seconds, it's everywhere 8 seconds, the LEDs, or to put it more accurately, the counting is not as logical, because for instance between the digits 2 and 3 it takes 10 seconds, but between 3 and 4 it takes 20 seconds, and those delays seem quite random. So, apart from the fact that it has slowed down, that is also curiosity. And I can't figure out yet why. And another thing is, as I said before, Ctrl+C. It used to work instantly, but even when I take the random, or maybe not so random, delay between the digits, and I hope you can see it, maybe if I make it darker you can see it more clearly. All LEDs or LEDs are off, so it's the digit 0. And even then, how long does it take to get to 1? Now here it goes to go, then you expect with this, and now it exits. So I have to wait quite a long time. I'll start again. It's 1. A very bright second LED. After 10 seconds it's 3, although this this LED is quite faint, but it does burn. And now, after a very long time waiting, it's 4. So let's see how fast it is turned off. And here suddenly there's a lot of code running, but that is of course because of here. So let's see how long that takes. And it just goes on. And it's off. So this is quite unlogical. And when examining this, it is from on, off, on. So this is the digit for 5. It goes to input state 1, which is reverse. Then it goes to off, on, which is binary for 6. So instead of reverse, it goes on and then it stops. So that's quite illogical. And let me stop this part of the code as well. See how quick that stops. Quite fast. So there's still on this front some weird thing going on. So let's examine the code for a while. And one of the things I have done is to remember which state it was on. And that seems to be not working quite quickly. Although no, the point is I put the remembering in what state it came from, not the digit. So that might be one of the points. So time to try to fix that. I just reasoned that I needed a variable to remember the state count, the count state. However, I already have that in the form of LED 1, 2 and 3. So that should mean that from this input state 0, if I have, for example, these values for LED 1, 2 and 3, and I change them to 0, 1 and 0, and here in control it goes into another state, either go or reverse. Then here you would say, okay, it's the other state, and I have, for example, 0, 1, 0, which is counting back, and then we would logically be here and put it back to 110. So the question is, why doesn't that happen? And the only thing I can think of is that this is somehow interfering with this pace, the pace of this program, and it is reading in, but is it reading in correctly? So let's here start control again. Let's compile, because I changed the code a little bit. And start. It takes a considerable time, as we noticed before. And well, it is on, see, and now it is indeed, it should say on off, and now off of on, which is correct. Input state is 1, so here from off on off, which is 2, to on off, and that is not correct, because this should be on off. So I think the problem is that the timing between the programs is the culprit, and the question is how to solve that. Another thing is, of course, that RPi1 and RPi2 have different clock speeds, but if that is of influence, I do not dare to say. Anyway, one solution would be, or could be, changing the 8 seconds. It gives more time to evaluate each state, but on the other hand, the delay I find in here is new, and these seconds have been there for quite a while, so that is just reasoning, and maybe that could change. So let's see if that is indeed the case. I'll let this one end for now. I'm ending this here. Risk is of course that it gets even slower, but that risk I will have to take. So from 8 I'm going to, oops, this is 1 second, so I add this is wrong. So that is a little better. Of course, a compilation. Let's start again. And of course this now takes 16 seconds. This is still coming to an end. And now it ends. So that takes considerable time. And here you can hardly see the first LED burning, and it burns unequally as well. Stronger and weaker and stronger and weaker. So possibility is that that LED is going to finish. Digit 2 now, which is correct. Three, which is quite a lot faster than the first one. But is it 16 seconds or shorter or faster? And the other problem is, of course, that this should just go on counting, while this is just lasting 10 seconds, 16 seconds. So the counting up should go fast enough for 16 seconds long, and this counting should just go on. So with all the reasoning, whatever the cause is, it is not in the counting, and that is something to investigate in the code, although I can hardly imagine I changed the code like that. The only thing I did change was something in here with input state, and after that it changed. But I think this is for another time. So with all this reasoning, there's enough left to do. So thank you for watching, and to be continued.